My name is Chun-Hua. I come from the South University. Today my presentation is about another low voltage large displacement Bulk Silicon Comb-drive Actuator based on Post-CMOS cascade. Our presentation will be divided into 5. First is the introduction. We will discuss about our motivation of our research. Second is the structure of the Bulk Silicon Comb-drive Actuator, which to give the optimization of the comb-drive actuator. Third is the fabrication of the comb-drive actuator, and then the result of discussion about the conclusion. First is the introduction. Comb-drive actuator was a type of the classical electrostatic actuators. They have the advantage of lower power consumption, high speed, good compatibility with microfabrication process. It was used in optical switches. The switches was usually used in the optical communication. And then it was used in nano manipulator, the micro capacitor, and the nano position excitator. What's the key factors of the comb-drive actuator? It is maybe the maximum displacement and the driving force and pulling voltage and frequency. The comb-drive actuator has larger maximum displacement and the larger driving force, and the lower pulling voltage it will be better. All these 4 factors is related with the side instability. The side instability is about the we determine we decide the pulling voltage. The side instability, if the side instability was decreased and the pulling voltage will be enlarged, the maximum displacement will be larger. This table shows the comb-drive actuators used to decrease the inside instability to have larger pulling voltage. In reference is 1, 2, 3, the 40 beam and the 40 beam was optimized to have a larger displacement. And the in reference is 4 and 5, the comb fingers was optimized to have large displacement. And in our work, we optimize the 40 beam and the non-initial overlap and account on the unequal wider comb fingers was also used to catch larger pulling voltage. Compared the comb-drive actuator we designed is not the maximum displacement of our design is not largest, but we get the smallest driving voltage to have more than 50 micrometers, and the area of our design is the smallest. The fabrication tolerance was also considered. Then we talk about the structures of the Bulk Silicon Comb-drive actuator. In the figure A is the normal comb-drive actuator, and the figure B was the we designed. In figure B was we designed the comb-drive actuator, which used the cascade 40 beam and unequal wide comb fingers, and the comb fingers was non-initial overlap. Then it is the 40 beam structure. In figure A is a usual 40 beam, and in figure B is a modified 40 beam. The 40 beam The spring constant of polymer beam is shown in here and here. And compared with two polymer beams, we found that the stiffness ratio of the two beams is same, but when the same electric force was applied on the two polymer beams, the modified polymer beam will have 3 times larger displacement than the usual polymer beam. Then we do some work, we do some research to optimize the combo fingers. The combo fingers used in this work was non-initial overlap. The side instability is related with the unbalanced force. The unbalanced force is shown in the equation 2, which shows that the unbalanced force is linear with the overlap segment length. As a result, when the overlap segment length is small, the unbalanced force will be decreased. So the combo-drive actuator with non-initial overlap combo fingers will reduce the side instability greatly compared with the initial overlap combo-drive actuator. And the instability is also related with the width of the fingers. When the fingers was not in the middle position of between the movable combo fingers, the electric force, the unbalanced electric force will be divided. By increasing the width of the combo fingers, they will decrease the decrease the side instability. So the deeper eye process will affect the ozone profile. Will affect the profiles of the combo fingers. This is the broken atom photos of the combo fingers, which shows that the combo fingers have negative ozone profiles, that will decrease the capacitance between the combo fingers. And the capacitance of the combo fingers can be calculated with this equation. Actually, in figure B, figure B shows a relationship between combo finger slope angles and the capacitance. When the combo fingers have negative ozone profiles, the capacitance will be decreased, and when the ozone profile was positive, the capacitance will be increased. Also, the if eye process will also affect on the stiffness of the polymer beam. When as shown in figure B, shows when the ozone profiles have negative profiles, the stiffness will be decreased. So when in this time, when the same electric force applied on the polymer beam, the displacement will be larger. Actually, in this figure, when the ozone profile is -1 degree, the stiffness of the polymer beam will be only a half, and in this time the displacement will be 2 times than the time. This figure shows the ozone profile. Shows the displacement of the combo fingers relationship with the single fingers with the sloping angles and the electric force along moving directions is shown in this equation, and the displacement of the comb fingers is shown in this. Next, we talk about the fabrication of the Bulk Silicon Comb-drive Actuator. In this work, we use the bonding technology to achieve the Bulk Silicon Comb-drive Actuator. There are three bonding technologies was used. First is the anodic bonding technology. It was used to bond silicon and glass. This bonding process needs a higher technology, a higher voltage, which will damage the CMOS IC, and is a fusion bonding between silicon and silicon. The temperature is very high. And then the last is the the gold bonding between silicon and glass. The temperature is about 400 degrees, and the bonding state is high. We do some research about the bonding stress. This three figures shows the bonding stress tester structure. The bonding stress is about 50 million pascals. Now we talk about the fabrication of the composite actuator. First, the shell girth was fabricated on the silicon wafer by IE process, and then the girth was patterned on the silicon substrate. The girth was patterned on the gas wafer, and then the gas wafer and silicon was bonded according low temperature gold bonding substrate. Then the silicon was sent to about 40 micrometers through CMP process. CMP process is short for chemical polarization. At last, the Bulk Silicon integrated electrode was released from ICP process. ICP process is deep IE process. It is a platform for the comb-drive actuator measurement. This is the theorem of the tester system. The semiconductor characterization system was used to measure the capacitance of the comb-drive actuator. Also, it was to give the power to drive the comb-drive actuator, and the three-division microscope was used to measure the displacement of the actuator. This is the result of the actuators. The displacement of the initial overlap comb-drive actuator, the displacement generated is about 0.125 micrometers per quarter voltage, and the maximum displacement is about 28.5 micrometers. The point voltage is about 50 voltage, and the non-initial overlap comb-drive actuator is 0.03 micrometer with the comb fingers now overlap in the range from 0 to 14 voltage, and mean voltage is in the range from 15 to 24 voltage. The displacement rate is 0.11 per micrometer per quarter voltage, and the maximum displacement is 50.127 micrometer. The point voltage is about 25. The major displacement change rate of the initial overlap actuator is large by 186.7 7 than the initial design. This is the reason the polytopium have the negative Augen profile, and the negative Augen profile decreases the stiffness of the polytopium by 62.35%. Consequently, this would increase the deflection of by 165.5 nm. Also, this is the capacitance change of the actuators, which shows that the initial overlap actuator has a different capacitance change when the run voltage is different. Now conclusion. A post-CMOS process was achieving bulk silicon capacitance, and the non-initial overlap anomaly was used to reduce the data and to improve voltage. The measure showed that it is a simple and effective way to try to achieving larger displacement by using non-initial overlap and unequal components. That's all. Thank you.